So let me start out drawing. So in the previous video, I used Lewis dot symbols to draw Lewis structures. And today I want to do, or in this video, I want to do the more traditional way to do it, sort of applying a few different rules. Like, for example, we'll be counting up valence electrons. We'll be following the, first then we'll be figuring out what the central atom is, and then we'll be following the octet rule. And then for this one, actually, formal charges we won't talk about. And again, this is a very traditional way to approach drawing Lewis structures. Now, previously, we had talked about using just Lewis dot symbols, like, for example, for carbon. Since carbon is one of the elements that's in the, let me clean that up. And since carbon is one of the elements in our molecule that we're going to draw in a second, let me just remind you, right? Carbon has that Lewis dot symbol. That should just be one electron there. And basically, those 4 dots represents the 4 valence electrons around the carbon. And it's those 4 valence electrons that are going to be used to build any molecule with carbon, okay? And the number of the number of valence electrons, is just simply counting over 3, 4, 5, 6, 7, and actually in some of the examples that we'll see in these chapters on Lewis structures, we will see these 3 elements showing up, and they have a valence electron count of 8. So you can imagine argon has, if you will, the Lewis dot symbol. And this is, I don't know if I talked about it directly in the previous videos, but it's certainly in one of the figures that I referenced in those videos. And then while we're at it, so the molecule that we're going to be, or the atoms that we're going to be using are those. So let's just get all of them down here. Right? 1 dot for hydrogen, and then oxygen has 6 valence electrons. And usually the way we treat it is something like this. Sort of go around one at a time. And the reason why you do it that way, I think, is it just keeps track of the fact that there's 2 points on oxygen, where bonds are going to form, basically, is what these Lewis dot symbols are, helping you figure out. Okay, great. Now, let's not use the Lewis dot symbol for drawing the structure. Let's go through the more traditional way. Now, so the first thing we want to do is count up the number of valence electrons, and what I was just talking about. Okay, for the carbon, there's 4 valence electrons. Each hydrogen has 1, and of course, there are 2 hydrogens there, so total of 2 valence electrons coming from the hydrogens, plus 6 more from the oxygen. So if I add all this up, what it tells me I have 12 valence electrons. Now, these are the 12 valence electrons I'm going to use to build a molecule, and I have to use all 12 of them. Okay, keep that in mind. You're always going to use the total number of valence electrons that you've figured out. And so the first step that you want to do is figure out what the central atom is going to be. Now, usually what we see in these examples is it's the first atom. And in this case, it's going to be the carbon. If there's an example where there's some uncertainty, I feel, in the notation here, I will tell you which atom is the central atom. Okay, so first single atom you see is, in this case, carbon. And then the other thing to note, and it's in the notes here, hydrogen's never going to be a central atom. It's always going to be on the outside of the molecule. Okay, so with that in mind, let's just start this thing off. So there's our central atom, and the first thing we want to do is basically, when we say Lewis structures, usually that means the simplest type of molecule that we're going to see for in chemistry, meaning there's a central atom, and then we just have a bunch of other atoms laid out sort of symmetrically around the central atom. So that's what I'm going to do here. And then what you do is you're going to take these valence electrons, and you are going to start connecting these atoms together. So I'm going to use 2 valence electrons there, 2 there, and 2 there. So what I'm doing is, right, each line represents a covalent bond, so 2 electrons. So what have I done here? Well, so I can say 6 valence electrons have been used in the, at least connecting the atoms together initially. And that means that 12 minus 6, all right, that's going to give me 6 valent electrons left over. Okay, so those 6 valence electrons, what's going to happen here is that they're going to be used to produce multiple bonds or lone electron pairs around the molecule. And what we're shooting for here is the placement of these remaining electrons so that we can fit the octet rules as best as possible. Okay? And I'll talk about octet rules in more detail a little bit later. Briefly, what we're talking about here on the next slide is this guy. So all we're doing here is just, there's chemical patterns that we see in nature. For example, hydrogen likes to see 2 electrons around it. These 4 elements, carbon, nitrogen, oxygen, and fluorine, they're always going to see no more than 8. Okay, so in a few cases they can have fewer than 8, but in most examples 8, and never more than 8. Boron and aluminum, you might see some of those. They can vary between 6 and 8. For sulfur and phosphorus are 2 examples in particular that can expand their octets. And so, plenty of examples. Are you going to have sulfur and phosphorus as with an octet of 8? But there's going to be plenty of examples where you might see 10 or 12 or maybe 14 or 16 electrons around phosphorus or sulfur. And then notice in the notation here, it's saying any element n equals 3 or greater. Okay, let's go back. What do I mean by n equals 3? Well, I mean this particular row. Okay, so anything, and notice what we have here. There's our 2 main ones. So these 2 in particular has a tendency to expand their octet, but pretty much anything from, this row and below, these large atoms down here can expand their octet. And you'll see plenty of examples of that, okay? Let's get back to drawing the structure. All right, so now that we know, so I've picked a relatively simple one. Okay, the carbon and oxygen is going to have 8 electrons, and then the hydrogen is going to have 2. Now notice the hydrogens already have 2. If I circle, how many electrons are around hydrogen? Well, there's 2, so it already has a valence electron, or we say it already has an octet of 2. It's not going to change on that end. It's not going to change here either. But carbon does not have an octet of 8. 2, 4, 6 for carbon. There's only 6. That means I need 2 more. And the typical way that we do this is that we're going to put a double bond between the carbon and the oxygen. I have an octet of 8 around the carbon, but now notice oxygen still does not have its octet. It's got 1, 2, 3, 4. All right. It still needs 4 more. Well, as it turns out, right, I still have 4 more electrons to place on the structure. Remember the little lines and dots in green that represents the 6 valence electrons that I had left over from the initial structure. And that's what we have here. 1, 2, 3, 4, 5, 6. So there are a total of 6 electrons. So the green coloration here, that represents the 6 valence electrons that are left over from that initial subtraction. And that's what we see. In the green here, there's 1, 2, 3, 4, 5, 6. If I go through and count all of my electrons, I have used all 12 of them. Octet rules are satisfied, and again, I won't worry about the formal charge discussion here. And in the next video, I'll break down a little bit more about the octet rule as well as the formal charge concept, just a little bit.